This is the Intro to Git and GitHub workshop presented jointly by Coder IT and the iSchool. I would like to, I guess, before we start, I'd like to thank Mark, Regina, and Abe for their support and planning for this, because this has been a fun little ride to prep for the past couple of weeks, but excited to show you all today the wonders of Git and GitHub. So, what is Git and GitHub? Because I don't know about you all, but when I first came to college, it was talked about a lot, and then no one ever actually sat down and really defined what it was. And so I'm just kind of curious is to get a little participation in here early, I guess. Has anyone heard of Git and GitHub before or have an idea about what they think it is?
Is it like a repository to store our code?
Mm-hmm. That is one definition. Any others? Cool. We will just run with that. Actually, yes, it is. That is one part of it. The interesting part about Git and GitHub is they're two separate systems, and we're going to go into that today. So Git is the industry standard version control system. Now, version control system is a lot of words to say, and as a computer science people, we like to abbreviate things a lot. And so we're going to just abbreviate version control system down to VCS. But this doesn't help matters. What is a VCS? A version control system keeps track of changes in your code over time. So you could think of it like, instead of just like basically hitting save every time you're done with something, every kind of set of changes of your code, like every time you, like, let's say you add a certain number of methods as you determine and be like, this is like a distinct change. It'll keep track of who made the change, what files were modified, what specific code was added or removed, and at what time the changes were made. It keeps track of all of this stuff. And as you mentioned, the code is stored in what we call a repository. It's basically, a repository is just kind of a container of code. It's a project. So for example, if you're building like Google Chrome, there would be a Google Chrome repository. That's just kind of how we define a set of code. You can think of it just like a folder. And Git also is not the only version control system out there. It is the industry standard. There are others, such as Subversion and Mercurial. Generally, if you see tech companies nowadays using Subversion or Mercurial, it's generally not a good sign, and they're probably a bit behind on the times. Every major tech company and startup basically uses Git. And after today, hopefully you'll see why. There also, just to point out, if anyone's familiar with, there are different types of systems, like Git is like a distributed system, but we'll be going over that in the next intermediate workshop, which is next week or the week after. And so another question I'd like to pose to y'all is, why would we need a version control system? What's wrong with just editing code the way we do? Like just saving it in the text file, hitting run whenever we want to run it. What could keeping track of all the changes to code give us? Is there any advantage to that?
Maybe if multiple users are using or have access to the same code, keeping track of the version will help when working in team structure.
Mm-hmm. That's a very good point. Yeah, because if you have multiple people working on your code, it's really hard to actually keep everything in sync, because you'd have to like save it to a drive, give it to someone else, they plug it in their computer, that kind of thing. Any other suggestions?
What if I want to, sorry.
Go ahead.
What if I wanted to revert to an old version of my code?
That's a very good point. Yeah. If you want to undo a bunch of changes you've made, unless you like literally duplicate your entire folder of code, that gets very messy very quickly. And adding some structure there would help. Anything else? These are all good answers, by the way. They're all correct.
Code reusability?
Yeah, that's a good one too. You could reuse code across changes, because if you keep track of what the changes actually are, you could then like kind of take that code out and use it in different areas. Funnily enough, that's actually a big area of research in software engineering, which is pretty interesting. So yeah, as we all mentioned, version control systems let you easily revert changes. So if you'd like commit, if you have a certain bit of code that gets input into the repository that's bad, you can kind of work your way down all the changes that have been made and be like, oh, this is when we added this bit of code. This is when it wasn't good. Multiple people can also work on the same code, and we'll talk a little bit about that later today. And also, it lets you have backups of your code, right? Because if you change a bunch of things and you suddenly decide you don't want those changes, it's effectively a backup, of like the older versions of your software. It's very useful when one day you suddenly realize that a feature doesn't work, And so you can just go back to the code the day before you noticed it stopped working and be like, okay, what happened here? It's very, very useful. Now, I've kind of mentioned Git and GitHub together, but these are in fact two separate things. So as we talked about, Git is a version control system, or VCS, and it keeps track of changes across files. And it's terminal based. It's all done in the terminal on the command line. If you're not familiar, we'll go a little bit into that today. GitHub, on the other hand, is an entire website platform for hosting Git repositories. And it also provides a bunch of other services on top of just like a place to put all of your Git repositories and view all sorts of the things that version control system gives you in terms of viewing history, viewing changes that have been made over time, who authored those changes. It also lets you do things like issue tracking. So if you have like a piece of software that has bugs, users can then come in and be like, oh, I'm having this issue, and like post a screenshot and like what exactly went wrong. It lets you do things like automated testing. So you can basically write other pieces of code that verify that your program works as intended. And then whenever you have incoming changes, just run the tests against those incoming changes and make sure that this small thing we're adding doesn't screw up the entire system. This also makes it very easy to track when we add something small that breaks everything, which does happen quite often sometimes. Finally, GitHub does some cool stuff like code annotation. So much like you can comment on text in Google Docs, you can also comment on code in Google Doc in GitHub, and you can have like little threaded conversations. It's very, very nice. And something I should also mention is similar to how there's different version control systems, there are also different websites that let you host Git repositories. Two of the most popular other ones are GitLab and Bitbucket. You'd be pretty hard pressed to find someone that uses Bitbucket. Universities generally use GitLab because it's a little bit freer and has a little bit less restrictions. But GitHub is generally the most popular. They were bought up by Microsoft a couple of years ago, by the way, so in case you don't like that. All right, so does anyone have any questions on what Git and GitHub are, just kind of generally? All right, so let's move on and dig into Git. And we're actually going to see how we can use it to keep track of our files. So Git has three main ideas. We have this idea of a commit, we have a branch, and we have a remote. Now, if you've used Git before, it seems a little bit strange that I'm creating this thing called a remote, but this is a way of just kind of organizing what we're talking about here. And so we're going to go through each of these steps, and by the end of this section, you'll have a very basic understanding of how Git works. So let's start with a commit. Now, if we open up our trusty little terminal here, which is either, we're going to go over later how to actually set all this stuff up, but this is like your command line on Windows, your command prompt on Windows, or your terminal on Mac. And let's say we change directory into our desktop, and we create a folder called Git Workshop using the make dir command, and we go into that folder. And let's say while we're in this folder, we create a text file. You can do this all through editor, by the way, if you want to. And since Git is an entire version control system, we can check the status of the system at any time. And this is something that we do quite often. So the way you do that is you type git status. Now, Git is not some omnipresent like system service running that is an overlord on all of your files on your computer. You have to actually initialize Git in a specific directory in order to keep track of all the files and subfiles and subfolders in a directory. So when I ran git status in this folder, it says, hey, fatal error, not a Git repository. So we need to initialize one. We use the git init command to do that. And once I run git init, it now says initialized empty Git repository in the path name. Now, the eagle-eyed among you will notice that it actually isn't creating it in the Git workshop folder. It's in this thing called .git. Keep an eye on that for the next workshop. The way Git is implemented is just absolutely fascinating, but we don't have time to get into that today. All right, so now that we have a Git repository, we can start thinking about the different stages that Git provides. And in order to give an analogy, I like to give the analogy of a restaurant kitchen because I was definitely not hungry when I wrote this presentation. So you can imagine you have a kitchen and you have all this working area, right? You have like all like the countertops, you have all the little ingredients you can use, you have the stove, you got everything you can need. When you start the day off, the working area is empty because no one's started making any food yet. like, yeah, there's like some food like in the fridge or whatever, but no one's actually working on it. And so that's the first area of Git, is we have our working area. It is any and all locally changed files. Now, you can imagine a bunch of chefs come in, start cooking up the food, they start making a salad, start making chicken, whatever else, and they make the food. Unless you're a really skilled chef, you can't just throw the food out the server window and have it land on the customer's table. It doesn't really usually work that way. What you need to do is you have to tell the server, hey, I'm about to give you this piece of food and I want you to take it out to the customer. Now, also, server can't come in the kitchen because they don't know what's going on. They don't know what food is ready or not. You have to be the one as the chef to be like, this specific dish is ready to go out to that customer. And so what you do is, you put it on the little window. And in Git, we call it the staging area. These are changes that we're about to put into a commit. These are things that we're about to say, these are the set of changes that I want to document. Now, usually this is everything from the working area, because if you think about it, why would you just change like a bunch of random files and only use a subset of them? Now, it is a use case we'll cover in the intermediate workshop, but for now, generally, we just kind of put everything in the staging area. Now, once you put things in the staging area and you've decided that your changes are like pretty much ready to go, at that point, you make a commit. And now is when we define what a commit is. A Git commit is just a discrete set of changes. That's all it is. And we'll look into more depth as to what a commit actually is a bit later on. But for now, this is just kind of the general structure of where we're going. So to kind of take this theory and put it in a little bit more concrete context, let's actually build a commit from scratch. Oh, one other thing. These are the commands we use to actually make these changes. So we would add files. We do git add is the command to add a file to the staging area. Now, why it's just not called git stage is far beyond me, but it's just what we have to deal with. But thankfully, the command to make a commit is just git commit. So let's go back to our terminal window we were at before, where after we did git status and git init. Now, if we let's just try typing git status again, because now we actually have a git repository initialized in our directory, and it should give us something a little bit more informative. Oh, actually, wait a minute. We can actually just already figure out what's going on here, right? Because since we've initialized a git repository, Git has no prior knowledge of anything because it's brand new. And so everything it sees in the directory is brand new, and it's considered a part of the working directory. And so our file that we created there on the second line, hello.txt, is just part of the working area because we haven't seen it. Git hasn't seen it before. It has no idea what's going on. And so it's like, hey, there's something in the working area. It's called hello.txt. And so that's kind of where we are in terms of our diagram. Now, if we run git status, Git's going to say a few things here. It's going to say we're on branch master, which we'll get to later. It says there's no commits yet. And we have untracked files, which is strange. They're in the folder and the Git repository is initialized. We certainly want to track them. Unfortunately, with Git, we have to explicitly tell it what we need to track and what we want to track as part of our version control. Thankfully, this is kind of bundled together in the process of adding it to the staging area. And so it even tells us, it says, hey, use git add and then the file name to include in what will be committed. Also, why Git just doesn't tell you that you could add it to the staging area is also beyond me. It's a little confusing. I think Git's only been around for about like 15, 16 years. I think it was written like 2004. So we can't even use the excuse that it's like some super old version of software. But what we can do is we can add our file to the staging area. We can do that with the command git add hello.txt. And now we move our hello.txt file is now no longer in the working area. Well, it still technically is, but conceptual purpose, it's in the staging area now because these are the changes we are about to put into a commit. And if we do git status again, just to see where we are, Git will tell us, hey, we got changes that are about to be committed. We got a new file, and that's it because there's nothing in the file. Git just knows we made a new file. That's all it is. So at this point, we can now do a git commit. Now, I am skipping a step here. So as part of a commit, because if you think about it, we have a discrete set of changes that we're making. It seems logical that we want to describe the set of changes that we're making with some sort of message to be like, hey, I'm updating a bunch of variable names. I'm deleting all of my friend's code. Like I'm doubling the efficiency of the algorithm we're using. Like there would be some sort of description. And so the kind of shorthand way of doing that is there's a flag we can pass called -m, followed by a little small description, which I'll talk about in a minute. And in this case, we just say, my hello.txt is now added. Something quite simple. And finally, our hello.txt has been committed. So if we head back to our terminal, Git has told us something a little crazy here. It says master root commit C257B06. My hello.txt is now added. 1 file changed, 0 insertions, 0 deletions. What does this actually mean? Now, you can imagine once you start making a lot of commits, you might just forget what commits you've made, which is, you're not expected to memorize all of them. There's a command that Git provides called git log that shows a log, a record of all the commits you've made. And so if you type git log, it's going to give us a few pieces of information. And so let's dig into that. So the first thing that you'll notice is there's this really long string of hexadecimal here for some reason. This is just called the commit hash. And something just to note, like in the back of your head, is that it's a unique hash, which again, we're not going to get into this workshop, but it's part of how Git works. It's absolutely wild. It also says something about head master. All we need to know is that this commit was done on the master branch, and branching is something we're going to talk about in the next section. It tells you the author, that's me. Git specifies you have your first, last name, and an email associated. And also it records the date fairly exactly. And it also has the message. Now, as I mentioned before, we kind of have a relatively short message here. And this isn't like a suggestion. If you type a really, really long message, Git will just cut off the message at some point and then start it on a new line pretty much immediately after 50 characters. And so if you want to have some longer description, what you would do is you would just type git commit with no arguments, and then it's going to prompt you and explain in more detail how to add a longer commit message. It's not too hard, but it's an extra step that we generally don't do. All right. So does anyone have any kind of questions on what commits are and how they might work?
I have a question here, not specifically regarding commit, but what if our code is in the staging area, and if I delete my code by mistake from the local, like from the system, can I retry it from the staging area before it is committed?
So as far as I'm aware, if something is in the staging area and then you delete the file or like the code that you've changed, as far as I understand, it would go back to the working area and Git would just kind of be confused as to what's going on. Staging area is more like just a kind of a check for Git to be like, okay, I'm about to put this stuff into a commit. So if you were to change those files, I'm pretty sure Git would just be like, okay, I don't know what's going on anymore. I lost track of that file.
Okay, thank you.
No problem. We'll talk a little bit more in the intermediate session next week or the week after about how to actually recover changes in Git. That's a little bit more of an advanced topic, but it's very important. Any other questions? All right, so let's talk about branching. Now, before we talk about branching, we're going to have to talk about parallel universes. So I saw this on Twitter the other day. A compiler engineer was talking about how we should describe branching as parallel universes. So that's where we are here. So when you make commits, kind of one after another, they're all happening on something called a branch. Now, a branch, in its purest definition, is just a sequence of commits. That's all it is. It's just a commit after commit after commit in a linear fashion. And we give this branch a name. Now, we can call this usually the master branch, but nowadays we're kind of moving them to call them the main branch. And so you'll see it kind of in both ways if you Google around. And so by default, main is the default branch just by convention. And as you make commits, they will just be made on the main branch. Sounds pretty simple. But let's say you wanted to do something a little different. Let's say you wanted to have another branch, another independent linear sequence of commits. Now, the reason why it's called a branch is you can kind of picture it like a tree. It's like you have a trunk going up, and at some point you diverge. You share the same base structure as the tree. You're not coming out of the ground all brand new. You got a bunch of trunk to kind of work with, but at some point you branch off and work on your own. So we can visualize that here with some arrows. And if we move over to this bug fix one branch, and we start making commits, the main branch has no idea what's going on. It is an entirely different parallel universe of what's happening. And we can also make commits on the main branch that the bug fix one branch has no idea what's happening. Because remember, they're parallel universes. They operate in parallel independently from each other. So my question to you all is, why is something like this useful? Why might we want to have two completely, well, not completely, but mostly separate sequences of commits? Or is this just some like esoteric thing they threw in Git just to be funny? Because that does happen sometimes. Any ideas?
I'm just throwing something out there. This might be completely wrong, but maybe like web versus mobile.
Web versus mobile. What do you mean by that?
Like the structure of what you want to create might be the same, but the way it appears and the way it's implemented is different because of different like operating systems. So
that is actually a valid use case of branches, where you have this one project, but you have multiple ways that you need them to be implemented, if I'm understanding that correctly.
Yeah.
Yeah. So that's one way you can go about it. I'll kind of detail a little bit more on the slide here. And so, yeah, so that's definitely one I actually didn't put in here. Wow, nice job. So yeah, one of the reasons is it allows developers to work in parallel. Because if you can imagine, if you have only one, I'm gonna use the pencil I've been filling with. If you have like one sequence of commits and you have a developer just like jumping in at random points to make commits, everything's gonna be out of sync and it's gonna be an absolute nightmare. Branches, basically, it's like you assign one developer to a branch and say, you can make changes on this branch and you can make changes however long you want. And at some point, you would integrate the branch back into another branch. That's a process called merging, and we're not going to cover that this week. Now, this also lets large changes being made independently. So let's say you have some like huge set of changes that we need to make. And if you're just kind of doing those while you're making a lot of small changes, it can be hard to keep track of what was the point of making this whole overarching refactor or change to your code. And so that's another reason. And one common thing that's kind of like a convention in Git is that the main branch is always what we call the single source of truth. It is, if you have a version of software, no matter what time of day, what time of year, you clone or download the repository, the main branch will always be like a perfectly valid working version of the software. So let's say you have version 1 gets released, that is the main branch. When you start to work on version 2, that's not ready yet. That's not stable. And so that gets put on its own branch. And at some point down the line, it gets merged in because it's considered stable. Now, there's a lot more to branching that we're going to get into in the intermediate workshop. I'm leaving a lot out, but the kind of thing that I want to get across today is just the fact that branching exists and that they're independent parallel universes of code that you can kind of move back and forth between. Any quick questions about what branching is? There's a lot I'm leaving out here. So if you have a question that's like, how do you copy things from one branch to another? Or like, how do you like delete branches? What happens? Those are kind of have some complicated answers, but might as well try if you have one.
I guess I did want to say that when you do have something for, let's say, like an Android versus native iOS, typically those will be put in different repositories. I think you'd seldom see it on the same repository with different branches. So branches are kind of more like working on implementing little bits that you will one day plan to bring back into your master or main branch, rather than having like branches forever. That makes sense.
Got it. Yeah.
Yeah, that's a good point. Yeah, normally when we have extremely divergent platforms, we would put them on separate repositories. Cool. So let's kind of move on to the final piece of the puzzle here, which is a remote. Now, I've kind of been talking this whole time about your own little terminal and your own little thing. But one of the things we mentioned at the beginning was it might allow this version control system, keeping track of all the changes coming in and out of a repository, allow multiple people to collaborate on a single project. And so if we can kind of visualize this, where we have your own main branch, let's say. It's your sequence of commits. And on GitHub, where you hopefully want to, you have some copy of your repository with all of your code, has its own main branch, right? Because it's a copy. It's not the same exact file that's on your computer and some server in California or wherever it is. And so we kind of have this problem of how do we keep these things in sync, right? Because if you're working on your project and you commit something, that's only on your local branch. That's on your computer. It's not on GitHub. You're not editing it live. And so at some point, you need to be able to upload the changes that you've made and download the changes from GitHub. Because remember, other people are modifying the same repository. Now, this kind of gets into something I briefly mentioned before, which is that Git is a distributed system. What that means is that everyone has their own copy of the repository, and at various points, they manually sync it. So they say, I want to, this is the terminology we would use. Like, I want to upload the changes that I've made, the commits that I made. I want to push all the commits that have since happened on my computer. And likewise, I may want to pull all the commits that other people may have made onto the repository, or commits that I just haven't downloaded because I got a new computer. That's the terminology we use there. Now, so let's jump back to our example from before, and let's dig into how we would actually upload our repository to GitHub. So I'm putting a small note here. There is some additional configuration required. For the workshop section after this presentation, we'll be going into that in detail. So if I just hop back in the repository and type git push and hope for the best, unfortunately, Git knows that we haven't set anything up yet, right? Because it tells us, it says fatal, no configured push destination. It says, okay, you're telling me to upload it, but like, where am I uploading it? Like, I'm uploading to Google, I'm uploading to Reddit. Like, where the heck does this thing go? We actually have to tell Git where we're uploading our files. Now, if you're using something like GitLab or Bitbucket, or you're hosting your own Git server, which you could absolutely do, this is where you would put the different URLs that you may use, which I'll show in a second. But Git tells us, okay, we can have this command called git remote add, and then the name of the remote and the URL, and then we can push to it by the name that we selected. And so it's typically convention, or it is convention, I should say, that we call our single remote origin. So if you're using GitHub, you would, as I'll kind of show actually in the next slide here, if you go to github.com and you create an account and you create a repository, which we will do after this presentation, it's going to give you a URL to use. And this is the URL that you would then insert when you're adding a remote, when you're connecting your remote, your local Git repository to the Git repository on GitHub. And you might say, well, wait, why don't we just call it GitHub? Like, that would be so much clearer. It's like you have when you go to push, you push to GitHub. It's just convention to call it origin. You can, of course, call it whatever you want. Excuse me. But again, just convention. Something to note is that you don't have to use this HTTP link. You can use this thing called SSH to upload, to pull and push from Git. It's a little finicky. We would strongly suggest sticking with HTTP. It's just that when you Google around about pushing and pulling, sometimes they'll bring up like SSH keys and all this other stuff. But for simplicity's sake, you should be fine just using HTTPS. And so this is great for uploading. And so at this point, we could then paste in the URL, type git push, and it would push all of our code up to the server. Now, what if we want to download code? Because the whole point of putting our code on GitHub is so other people can view it, right? And so other people can download it. And so if we want to download someone's bit of code, like I want to download Mozilla Firefox, like all of the source code for Mozilla Firefox, how would I do that? Well, there's a nice command called the git clone. Now, this is what I've been referring to when I say we clone a repository. It's just a way of saying that we're going to take whatever's on GitHub and we're going to download it to our local machine. Now, it will then what you do is you type git clone followed by the URL of the repo, which I will show in a moment. And it'll automatically create a folder in your current directory with the title of the repository in there. And it'll say like enumerating objects, counting objects, blah, 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 blah. But all you got to do is wait until it's finished. At which point you've cloned the repository to your local machine. Now, there's something I should mention, because if you're sitting here like, oh, cool, so I can just download Mozilla Firefox web browser's code and then like modify a bunch of it and then just do git push, and I've suddenly made changes to Mozilla Firefox. This is where kind of branching and GitHub comes in. So I'll talk about that a little bit later. And also something to note here is that I'm kind of hiding behind the curtain a little bit here. Pushing and pulling are technically, there's a third option in between here. And so, as we mentioned, pushing is like pushing your code up to the server. Pulling is pulling it down from the server. Now, pulling technically does two things. And so if you do a bit of Googling, you'll see that you actually does something called fetching and merging. So pulling is kind of built into two steps. It will download everything from the server, and then it will merge it locally into your branch. But the details of that we'll cover in the intermediate workshop. Again, for this workshop, we're just kind of covering the fact that you can push and you can pull. And for most cases, pulling is fine. You only encounter some people who are like, never pull, always fetch. But realistically, you can pretty much always pull. All right. Are there any questions about how remotes work? Pulling, pushing, any of that stuff? All right. And so that concludes a very, very basic overview of Git. Now, something I want to stress is that Git is complicated. And when I was making this presentation, myself, Regina, and Mark had to look up a lot of these commands and double check all of this stuff. There's a lot to it that we always constantly have to look up and reference. If you want, there are Git cheat sheets that you can download that will just have the list of commands, like what every command does. And those are helpful to have when you first start out. But there's also a lot more that Git provides. And so what we've shown you are just pretty much the basics that you will use basically every day as a software developer, software engineer, anything of that trade. And so just kind of know that while this might seem a little bit overwhelming at first, or just a little bit confusing, just by the fact that you'll be doing this for basically your entire career, because this is how all companies, they all use Git or some form of it, it'll eventually become second nature. And there's commands that like I was like talking with Regina earlier, like there's commands that like I've used like every single day that she'd never heard of, and commands that she uses every day that I've never heard of, which we're going to cover more in detail on the intermediate workshop, which I mentioned several times now, but there's a lot we want to fit in. So let's kind of shift gears a little bit and talk a little bit of just a little bit about GitHub, because GitHub is its own beast. Now, here's a screenshot of what GitHub looks like. And you'd be like, whoa, wait a minute. What happened to my terminal? We spent all this time, we spent 40 minutes in the terminal, and suddenly you're showing me a website? I could have just clicked around and done this the whole time. Actually, yes. So GitHub has a very nice interface for actually using Git. And when I say interface, I mean really just as a read-only type thing. Like, yes, you can edit files on GitHub and make commits using that. Yes, you can view commit history and do all this sort of stuff. But GitHub gives you a very limited interface to do these things because it's really just meant as a place to store them. Where GitHub really shines is in these three things, that main kind of pillars that they add, which are issues, pull requests, and testing. Now, I'm actually going to hop over to, what's a good repo to use? I'm just going to use the CodeRIT and then BitHack mobile repository, just because it has a short file list. And so if I so this is what a single repository looks like. We have a bunch of files here in the middle, and this is our code. We have a little about section here. We have some tags, we have releases, we have a list of everyone who's contributed. GitHub tells us what languages, what code languages make up most of the repository. And we have this thing called a README. Now, just to kind of briefly mention, every project has a README, and it's just a file that describes what the heck is going on, which we'll get to in the workshop. And for those of you who are at the Clayhack presentation, it uses Markdown. And if you're not familiar with Markdown, do some Googling. It's really cool. So, but where GitHub's features are all along the top here. So we have issues, and we have pull requests, we have actions, we have projects. There's a lot of stuff in here. And just to kind of show them to you all, we have issues, and issues are just kind of little bug fixes here. So one example is like, hey, it'd be nice if we could show a modal after login that could do this and this and this. We can tag them with labels. Notice there's no code here. This is not affiliated with the code at all. These are just extra features that GitHub provides on top of just being able to view and host a repository. We also have pull requests, which we're going to get into more detail, maybe in the intermediate workshop, I'm not sure. But this is where you do things like code review, which if you've had any experience with a co-op or have started looking into them, some job applications might have mentioned things about code reviews. This is basically where that would be done. Actions are fairly new to GitHub. They're basically a way to automate a bunch of things. So as I mentioned before, like when you push, let's say you push like a bunch of commits up to the server, GitHub can then run an action that basically tests all of the incoming code against like some known like series of tests. And you can do some pretty cool things with that. You can also set up these things. You can also set up other things in here. So for example, if you have like a Slack channel on your Slack server for like a class or whatever, you can actually connect a Git bot in there. So every time somebody makes a commit and pushes it to GitHub, it sends a message into Slack. So you can do cool stuff like that. Some people even set it up to like little like lights on their desk. And so like every time someone commits, like a big red light goes off. Good times. Anyways. So that's just kind of the brief overview of GitHub. There's a lot more to it. At some point, we're planning to do maybe an entire workshop on GitHub. We'll see. But just know that it has a lot of extra features on top of Git. Oh. Apologies. I'll just repeat that for a second. Yeah, so that was just a brief overview of GitHub. There's a lot more to it, but we just kind of wanted to show you the general overview for this. Any questions about GitHub, like what it does? Is it just like super confusing what GitHub is? It just seems like this thing that can do everything, or any questions at all?
For example, if you were working on a project by yourself, would you just use Git or would you also be uploading things to GitHub?
Good point. So that's actually a really good point. Yeah. The number one thing that recruiters will probably ask you for, aside from what your name is and what your LinkedIn, is what is your GitHub? So GitHub is, actually, I'm just going to go to my profile over here. So GitHub, if it can store all of your code projects, why not just upload all the projects that you do maybe as part of like your own personal portfolio? And so you can do that. And so for myself, just on my own profile, I have some projects I've worked on and I pin them right to the top here. And so recruiters at any company can just kind of go in here and start saying, hey, before we hire this person, what kind of code do they write? And this is something that can actually land you potentially a co-op. It's very, very encouraging to see. And you can, of course, add like emojis and like little descriptions and like links to everything else. It keeps track of all the repositories you've like committed to and stuff like that. But to kind of answer your question, I personally like to put things on GitHub even when I work on them solo, because I don't have to worry about like backing them up anywhere. Putting it on GitHub is the backup. It's like I have projects on here from like 6 years ago that just will always be on GitHub. So yeah, I would highly recommend. And something to note is please don't upload class assignments on GitHub as a public. You can have a repository be private or public. Please don't upload class assignments as public, because then anyone can view them and copy them, and that's no fun. So if you do decide to do that, private repositories are the way to go.
Also, to comment on that, you can suffer legal action, potentially.
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 Yes. So just be a little careful about that.
I just wanted to mention that it might be, especially when you're starting off, you might think it's just easier to do everything on GitHub, but once you get used to it, using Git in your terminal is extremely fast. And also GitHub has some certain limits, like you actually can't upload a lot of files at once on GitHub. So if you have like a project that you're working on that has a lot of files, and they typically do, it will be very hard to actually create a repository with all those files through GitHub. Whereas if you use the Git terminal, you can literally upload hundreds of files with one line of code, and it's very quick. So that's another reason to know how to use both.
You can upload millions of files through the terminal. Something I should also mention is, just as like a brief thing, because I didn't put it in the presentation, is there are applications that let you use Git without using the terminal. Like they let you like click checkboxes to stage things and stuff like that. They're GUI clients, as we call them. GitHub Desktop is one. There's like Tower. There's GitKraken. However, I personally strongly recommend suffering through using Git through the terminal, because the kind of point of this is to understand like the process of using Git. And it can be very easy, especially as a beginner, to just like forget about what's actually going on. Like forget about the staging area, forget about like pushing, pulling, fetching, all that stuff. Because the GUI sometimes doesn't do a good job of explaining what it's actually doing under the hood. So we would strongly recommend starting with the terminal, working through things kind of line by line, as we'll show in the workshop. So that finishes GitHub. So now let's dive into the workshop portion of this. But first we need to do a little bit of setup. So we've kind of written a guide on some example exercises. We have 3 example exercises. But before we get to that, we need to make sure everyone has Git installed on their system. So if you're on a Windows computer, you would download this thing called Git Bash, and it's at this URL, gitforwindows.org. Mark, if you could throw a link to that in like the Discord channel,
No problem.
for Git Workshop, that'd be great. And is anyone here on Mac or Linux out of curiosity?
Yes.
Cool. So what I recommend is open terminal and then type git space -- version, and it should either just work or it should prompt you to install something called Xcode command line tools. Installing that will install Git and like a bunch of other stuff, and that's what you want.
For Mac OS, if you already have Git, is there a version that that I don't want to say you want us to have, but like,
As long as you have it installed, it's fine.
oh, okay.
All the functionality that we're going to be covering in the workshop is pretty much on all versions.
Mm-hmm. Yeah, Git is like the only new things that Git adds is like they add like a couple extra commands here or there, or they add stuff that's like it supports uploading like a gigabyte of a single file, which it didn't do before or something like that. So we don't need that. Fun fact, Git was written by Linus Torvalds, who's the guy who invented Linux. Just got to throw that out there. So his name comes up. All right. So does everyone have Git Bash installed? Except for Grace, who presumably installed Xcode command line tools.
No, I think it just came with my Mac. I don't know, honestly.
Oh, well, that's convenient. by the way.
As long as you type git version and it popped up with like git version blah blah blah, like you should be good.
Yeah, it did.
1 point for Mac OS.
All right. Just want to mention we're asking because with the workshop, this will require like you to be actually able to type it in yourself. So just re-clarifying again, like we all, if you could have like a thumbs up if everyone has Git Bash or Git on their device.
All the thumb emojis. You might ask, why do we have to download Git Bash as part of Windows? You can install Git in another way, but it's like through the Windows subsystem for Linux. But if you just download Git Bash, it just gives you a terminal that will just work and has like everything in it. So that's why we recommend that. Any luck, SJ, Victoria, or Priyanka? Or you guys installed?
Yep. I already have it installed.
Cool.
Any less stragglers?
And if you do have issues, feel free to kind of reach out to us and let us know what's going on, and we'd be happy to help set it up for you.
Yeah. All right. So I'm going to move forward a little bit. If you don't have a Git Bash installed, oh, cool, got it. Yeah. If anyone has any issues or any further issues with Git, we're going to get into that in a second. So what we provided, or what we're going to provide, is a README file, which will have 3 exercises for you. So the first exercise is going to be cloning a repository. And so this is just talking about literally how to use the git clone command. And we have it as its own example because it's one of the most common things you do in Git, or can do. Exercise 1, that was exercise 0. Exercise 1 goes into just kind of the general Git flow that you might do, where it's like you modify a file, you add it to the staging area, do a commit. And And then exercise 2 is like a quick example, is a quick bonus one where it goes into actually creating a branch. Also to note, exercise 1 does require you to create a GitHub account and push to your brand new repository to GitHub, as we discussed in the presentation. And so you might say, well, what if I get stuck? Because we're not just going to set you all loose and do all this stuff. Well, we are, but with support. So in Discord, which I will provide the link for momentarily, if everyone isn't already there, we have a series of channels here for help. So we have a bunch of voice channels for different points. And so we have Git Workshop, which is like the main one. And we have Configure Git for if you have any issues configuring Git, setting up credentials, that sort of thing. And then we have kind of checkpoints along the way. So if you get stuck cloning the repository, just hop in that voice channel and ask what's going on. You get stuck writing a commit, like something goes wrong or the staging area just isn't responding how you want it to, hop in there. Alternatively, just ask in the text channel and one of us will be there to help. As a quick wrap up before we actually fully dive into the workshop, just some parting resources. So some things I want to mention is GitHub provides this thing called a student education pack. It has probably thousands of dollars worth of like free software credits for stuff. Like it includes like a year worth of like a domain plus hosting for a website. It includes like a bunch of free tutorials from like professional screencast things. It includes like a bunch of free credits for like Google Cloud and all this other stuff, like a bunch of really cool APIs to use that are normally really expensive. It's completely free for students. You just throw in your RIT email and they'll approve you in like 2 days or faster. And it's a very good resource. Something I didn't put in here is lynda.com. We get a free subscription through RIT, and they have some amazing deep dives into Git that talk about both the basics as well as a little bit more advanced concepts that we didn't have time to discuss today. Also, honestly, Google. It can be frustrating, but it has a lot of resources available. And that concludes the presentation section, and we will all dive into the workshop. Now the link is provided here, discord.gg/VR lowercase w 3 lowercase f capital F9. And so if you're not already in it, there's the link. And if you're in it, feel free to just ask away in the channel if you have questions. And something to note is the repo URL for this is the first one here. So this is the, it's on Regina's account. It's the Git Beginner Workshop repo link. And so this contains the file that has the exercise guide. So yeah, hop on over. I guess we'll also, we'll hop into the Discord voice if we will end the Zoom here. As if you have questions, you can just hop in any of the channels you need for help. Anyone have any final questions about Git or anything else? All right, thank you all for coming. Of course, please try the exercises. We'll be here for like the next little bit to help through those in Discord. And of course, we'll be having another Git workshop. I think it's finalized next week, right? Next Friday?
Yes, next Friday, same time.
Cool. So next Friday, I think it's the 23rd at the same time, we'll be going over the more intermediate parts of Git. So we'll be talking about Git stash, Git blame. We'll talk about branching. We'll talk about merging. We'll talk about GitHub in more detail. We'll talk about pull requests. We'll talk about all sorts of fun stuff and maybe go into a little bit about how Git works under the hood. So thank you all for coming here.